Good evening, all. Uh, can you see the screen?
No.
Yeah. Yes, I think.
Yeah. Okay. So we discussed yesterday. So basically, this is going to be the doubt session, as you all know. Yeah, we can start, right? So whatever doubt you have, you can just let me know, and we will try to solve them together. I will go through the assignment questions. So let us start with the activity questions. So whatever doubt you have from activity questions, let us know first. Then we will go to practice assignments. Yes. Anything from activity questions? Have you already solved them? Have you already solved them or not?
Not all of them.
Ma'am, not all. I think the last two are pending for me.
Okay, activity question. Okay, so whatever you did, then maybe you have some doubts, so you can share them.
I do have some questions, but not very specific to an activity, but it's to okay. I'll just try and look for that particular question and come back.
Yeah, sure. Anyways, and even if you have the screenshot or anything of that particular question, you can also share it in the chat box. Let me know. I can also pick them from the chat box too. So, yeah.
So in one of the videos, can I go, or is there someone else? Wait. Hello.
Yeah, you can go. Yes.
Yeah, ma'am. So in the video, it said that even if something is injective,
Yes,
and something is surjective,
yes,
there are still some conditions which needs to be met in order for something to be bijective. So I didn't understand that part, that it is not enough if it is injective and surjective.
which part are you following? Like, if it is both injective and surjective, then it is bijective.
It is
the
bijective.
definition. Yeah.
As per definition, that is the case.
Yes.
Okay. Okay.
Yes, yes, yes. So the definition of a bijective function is it will be both injective and surjective. But it can be like that, that if a function is only injective or only surjective, then it may not be bijective. Okay. In order to be bijective, it have to be both surjective, injective. Okay.
Okay. Okay.
Anything else?
No, ma'am. Is it possible for you to give me a small little example, if you don't mind? I mean, it's.
Yeah, sure. Okay. So just if I take this x equals to x square, and suppose our this is our range and domain, then this function is clearly onto, right? Injective, right? For any positive number, there is a pre-image of that number under this mapping, right? Agree?
I am not sure.
Okay, so we can check it, right?
Yeah.
How? That we can start with any arbitrary number in the codomain. Okay. Then what is our aim? Let us write down the aim. What is our aim? Our aim is to show that there exists a x belongs to the domain of the function such that f is pre-image of y. That means f of x equals to y, right?
Yeah.
That means we have to find that x, right? That means f of x equals to y means what? We know that f of x equals to x square. That means x square equals to y. That means x should be equals to root over of y, right? Now, because y is a positive number, so root over of y is always defined, right? Right? If y were some negative, then root over of y was not defined. But because y is greater or equals to 0, so under root y is always defined, right? So x is basically, it can be plus minus of y. That means the image of plus minus of root over y is actually y, right?
But if it can be plus or minus,
yeah, it can be both plus or minus. That means what? The plus y is not equals to minus y, but their functional image are actually same. That means this function is onto, because for any y, we can find a pre-image for that y, right?
Ma'am, so here f of x is equal to x square, is it? What you've written is x square.
Yes, it is x square.
Okay. All right.
Okay. So you have to find, like, if you want to prove a function onto, then you have to start with a random point in the codomain, and then you have to do the same steps. F of x equals to y, then you have to find the value of x. If the value of f is defined throughout the codomain, then the codomain is nothing but range. That means you can define the pre-image of that particular point, or for any point you can define the pre-image.
Okay. My question is, madam, here, because the pre-image can be minus or positive, right?
Yes.
So you have two different pre-images, right? For one. Yes. So by definition, it's not surjective, right?
No, it is surjective, because surjectiveness says what? That for any point in the codomain, you should have the pre-image of that point. That is what we have, right? For any y, we have such x's. But this is not one function.
Okay. Because this is because y is always positive. Is that why?
Yes, because our codomain is positive here. That is why for any y, we can define a pre-image. That means our function is onto.
Okay. So you can define it like this also. You don't have to define it as, all of real numbers or all of integers. You can define it.
We can define it, because range is always a subset of codomain, right? So we can define the same function from R to R. This is defined, but the function will not be onto from R to R. Are you getting the point?
Yes.
If the codomain is 0 to infinity, then f x equals to x square is on. That is what we already proved, right?
Yeah.
Now, if the codomain is whole real number, then for the negative one, we cannot define root over of y, right?
Yes.
Root over of negative something, it will be a complex number. So we cannot define that. In that case, this function is not onto. Okay.
It's not onto.
Okay. Now, again, if we restrict the domain, here our domain is R, okay? When the domain is R, then the function is not 1, right? Because of this plus minus. So y, root over y is not equals to minus root over y, but their images are same, right? So the function is not 1. But suppose if we restrict our domain to 0 to infinity, then the function f will be 1 onto, right?
Okay. Yeah.
Because we are just excluding the negative points. So now we have only one pre-image for one point, and we have pre-image for each point. If I take the function from 0 infinity to 0 infinity, right? That is what? It depends upon the domain and codomain whether the function will be 1 onto or not, right?
Yeah.
That means if I take the same function, but from 0 infinity to 0 infinity, then it will be both injective and surjective. That means the same function, it will be bijective from 0, 1 to 0, 1.
So, madam, here, I see that the domain is defined as 0 to infinity also.
Yes.
So which means for, let's say, if the x value was -2, it would give you a 4, and 2 also gives you a 4, right? So which means it's the two different values of x giving you the same y value. So
Yes.
how can that be injective? Sorry, I'm asking too many questions. I
No,
just
it's
can't.
fine. It's good to ask some questions.
Yeah,
I to answer them. So the thing is, if the domain is a real number, then you can do that. Like you can take -2 and +2 from the domain, and their images are same. So the function is not 1, 1 when the domain is real number. But if I take the domain as 0 to infinity,
Okay,
then
okay,
-2
okay.
is not there in the domain, right?
Okay. I mean, I totally forgot about that. Thank you, ma'am.
Yes. So is it clear about?
Yes, it is clear. Although a lot of times, when in problems, especially, there's just a relation expressed, but from that relation, it is not easy to guess what the codomain is, right? Because the codomain a lot of times is assumed that it includes negative values also. But in this particular example that you showed me, the codomain is very well defined in a way that there are only positive numbers. But in such problems, why is it that people imagine that the codomain?
Yeah. So for that, we have some steps. Like, so if you have a general function given without mentioning the domain and codomain, so your first job should be to determine the domain of the function. Okay.
Okay.
That means the region where the function will be defined. Okay. So for example, if I take, let us start with some easy example. See, if I take x -1, this as our function, and suppose you have to find the domain of the function. Okay.
Okay.
That means you have to find the set of all points where we can actually find the finite value of that function, right?
Okay.
So what should be the set of all points according to you?
So x can't be 1.
Yes, because 1 by 0 is not defined, right?
Yes.
But if x is anything other than 1, then we can define the function, right?
Yes.
That means
Yes.
the domain should be what?
It should be
Real line
minus infinity to open bracket 1.
Union
1 to infinity. Yeah.
They are basically same, right?
Yes.
So basically, we are excluding the point 1 from the real. So that means what? We have the domain of the function. Now we can find the codomain or the range of the function from the domain. So we have to check the function at the boundary points of the domain. So here the boundary points are -infinity, 1, infinity, right?
Yeah.
And from, if I approach to 1, we have two different sides. We can approach 1 from the negative side and from the positive side, right?
Okay. So, ma'am, sorry. So when you say boundary, the boundary, the inside boundary is also respected, is it? The 1 and 1?
Yes.
It's not just the outside boundary, which is -infinity and positive infinity.
Yeah, no, we have to also check, well, when x is, we have to basically check when x is going towards infinity, then the behavior of the function. Okay, so it is the end behavior of the function, right?
Yeah.
And when x is going to infinity, then we have to check the behavior. Then again, we have when x is going to infinity, 1 minus means from the negative side of 1, and x is tending to 1 plus means from the positive side of 1.
Okay.
So these are the boundary things, right?
Okay.
Yeah, that is what we have to check. Now let us start. So if x is going towards -infinity, then x minus, what about the nature of fx?
Fx would be 1 by
1 by
-infinity -1, right?
Right. And -infinity -1 is again -infinity.
-infinity.
And 1 by infinity is what? Tending to 0, right?
Tending to 0.
That means then f of x will be tending to 0.
Yeah.
Similarly, we can do for infinity also, right?
Yeah, it can be tending to 0 again.
Yes. If x is tending to 1 from the negative side, then what will be the behavior of fx?
It will be again infinity.
You just need to think about it, whether it will be infinity or minus infinity.
Oh, it will be minus infinity.
So why is it so?
Because it's a value which is greater than less than 1. It's a
X is
value.
somewhere here, right?
It's a value less than 1, so which means
Yeah.
it should be minus, right?
Yes. So that means if x is tending towards 1 from the negative side, that means x minus 1 will be tending towards like 0, but from the negative side, right?
Yeah.
So x minus 1 actually tending towards 0 from the negative side. That means we have a negative sign in front of the function. So this
Yes.
1 by 0 will be tending towards negative infinity, right?
Negative infinity.
Similarly, for this, what we can conclude?
For positive, again,
right?
yeah, it'll be
X
it'll
minus
be
1 will be tending to 0 from the positive side.
positive side.
So this will be positive infinity. So that means what? Our function is going towards negative infinity, towards positive infinity, and towards 0 from the both side. But it can never be 0, right?
It can be 0. Yeah.
That means what should be the range now?
It'll be minus infinity to open bracket 0 and union open bracket 0 to infinity.
So this is the range. Okay. That is how.
Okay.
Okay. Now codomain can be anything which is a superset of the range, right? Right?
Yeah. Yeah.
Now, once you have the range, that means codomain can be anything, which is
So
superset of the range.
It'll be minus infinity to positive infinity.
It can be the real number. Yes.
Okay.
Codomain can be the range itself. Codomain can be the real number, but mostly you have to find the range. Okay. And this is the like typical way for normal functions. You can follow this way to find the domain and codomain. Okay.
Sure, ma'am. That's very, very extremely well explained, ma'am. Thanks a ton.
That's good. Okay.
Ma'am, is there? Just wanted to ask you, would there be a recording of this session?
Yes. You can go to the live section, and it's being live streaming, so you can.
Sure. I'll just review this once again after.
Okay, sure.
Thank you, ma'am.
So just to recall the steps, whenever you have a general function, you have to find the domain and range of the function. First, your job is to find the domain. That means the region where the function is defined. Now, once you have the domain, you have to check the boundary points and the approaches. You can go to the points, and you have to check the behavior of the function near the boundary points. Okay. And depending upon the behavior of the function, you can actually comment over the range of the function.
Okay. All right, ma'am. Thank you.
Yes. Anything else other than that?
For me, this is it right now.
Okay. So you solve those practice assignments or not?
This particular one was a little challenging for me because I made a few mistakes and I just couldn't understand the concept, So
finding the domain and range.
Yeah.
Okay.
It was always a bit.
So what I think, there must be some other question about finding the domain and range of a function. You can see, there are so many questions. We can maybe do some more question.
Sure.
Okay. What about the first one? I just want you guys to solve it. So what should be the domain of the function? That means the region where the function will be defined, right?
Yeah. So x cannot be 2.
X cannot be 2. Right?
2. Yeah.
So this fourth option will be correct, right? Real line minus 2.
Yes. Yes. And the product of the minimum.
Okay. Yeah. Let us try to solve the second question. So
Okay.
I'm just giving you 2 to 3 minutes to solve the second question. Then
Okay.
we will discuss.
What does this mean, madam? The product of the minimum value of the function?
Okay, so we have the function. So you have to find the minimum value. That means the minimum image value of the function and the maximum image value of the function g and their product.
Ah, okay.
Okay.
All right.
Let us
Can you
check
go?
the answer also. Yes. Here, say something.
Yeah, ma'am, can we just see that question again, if you don't mind?
Yeah, sure. Yeah, this is the question and answer is also there. So
Okay.
what hint I can give you that you just try to think about the domain and codomain, especially the domain of the function, and then try to think what should be the minimum value of the function f and what should be the maximum value of the function g.
Okay. So x cannot, okay. Can I see the rights? Okay.
Are you finding the answer?
Almost there, madam. I mean,
Okay. I'm waiting for some.
oh, okay.
Is it done?
Yeah. I mean, so I think for fx, it cannot be, x cannot be 8 by 9, right?
Okay, so see, here we have fx equals to 9 modulus of x minus 8. This is actually a function. We don't have anything like in the denominator, right?
Yeah.
We basically need not to be worried about the domain, because if I take any real number, it will be defined.
Yeah,
if I take 8 by 9, then the value will be 0, right? So 0 is a finite number. There is no.
Okay. So 0 is the minimum of x.
No. So we have to find the minimum value, and what we will do, we will start with the equation of the function. So we know that the modulus value is always greater or equals to 0, right?
Yeah.
So 9 into this, that means multiplication of two positive number is again greater or equals to 0, right? So
Yeah.
if I just do this, minus 8, which will be greater or equals to minus 8, right? And this holds for any x belongs to the real number.
Yeah,
right?
yeah.
That means what is the minimum value of the function f?
But if minus 8.
Minus 8. So this is the minimum value.
Yeah.
Is there any doubt here?
No way. No doubt.
Okay. Now, similarly, again, modulus of something is greater or equals to 0. But if I take negative of that number, it will be definitely less equals to 0, right?
Yeah.
Now, if I sum 11, so it will be less equals to 11, right?
Yeah.
We're just adding 11 in both the sides. That means this is the maximum number of the function g, and this holds for any x belongs to the whole real line system, right?
Yeah.
For all x belongs to the real line system, right?
Yeah.
That means the maximum is 11. So what will be the multiplication? This. That means
11
minus
into 8. Okay.
Clear?
Yeah, it is, ma'am.
Okay. Let us now do the fourth one. Again, I'm giving you some time to just solve the question and let me know
Sure.
what is the answer coming. The fourth question. Okay, we have to check whether the function is 1, 1 or onto or not. Okay.
Okay. So, would you recommend that we do the find the domain first and?
No, here domain and codomain is given there, right? Domain and range codomain is given as natural number.
Okay.
That means we have from 0, 1 to infinity.
Okay.
Right?
So when you give something like this function where, okay, because of the arrow, you know that it's the domain and codomain.
Yes. So the first set is always the domain and the second set is always the codomain. Okay.
Okay.
Now you have to check whether the function is 1, 1 or onto or not. So we
Okay.
will go with the definition. If you want to find it is 1, 1 or onto or not, so we will start with the functional image of two different points, and we have to check whether they are same or not. If not, that means if not 1, 1, so we have to find an example.
Okay.
And for onto, we have seen the example of f of x equals to x square, right? How to prove a function onto. We have to start with any random point in the codomain, and then you have to check whether there is a pre-image for that point or not. I will solve them. Before that, I am giving you some time to solve it. Let me know.
Sure. So if two different x gives you the same y, which means it's not a 1-to-1.
1,
right?
1. Yes, correct.
Okay. So this doesn't seem like a 1-to-1.
Do you have an example?
Yeah. When you put n is equal to 1, then you get a 2/2, which is a 1. And then when n is even, which is like 2, 2/2 is again gives you 1.
Correct. So f of 1 is equals to f of 2, but 1 is not equals to 2. That means not 1, 1. Correct.
Not 1-to-1.
Yes.
Okay.
So this
Now
is not a 1, 1 function. Now you have to check for the onto. Is it onto or not? If you think it is onto, then you have to prove it. And you have to start with some random point in the codomain, and you have to arrive to the pre-image of that point.
Ma'am, this function seems to be onto, ma'am.
Okay. So what are the steps you took to prove it?
So for every image in the codomain, there are two pre-images. Or except 0, there are two pre-images in the domain. But ma'am, how will we do it mathematically? That is the question.
Okay, that means basically if I take any point in the set of all natural numbers, suppose for n belongs to natural number, so basically we can define a number for what can be the pre-image of that number, right? Right?
Yes,
So this
I think
n,
we should write like here. Yes, ma'am. For any n in the codomain, there are, except 0, ma'am, there are two images in the domain and which can be expressed like this 2n plus 1 and twice of n. These are the two images.
But
Yes. Yeah.
ma'am, so when you try to take like something like 99 as a value of y, and when you try to work the value of n backwards, you're getting a decimal, which means that's a fraction.
No, if I take 99, just try to think 2 into 99 minus 1. What is the image of that number? It is a natural number, right? 2
Yes,
into 99 minus 1. What is the image of that number?
Yeah, it's a 197. So that is also natural. Okay.
Right?
Yeah.
So this, how can we prove that mathematically, step by step, is if I take any natural number, we have two ways. That means it can be even, it can be odd, right?
Yeah.
So if it is even, then if I take a number 2n, so the image of 2n under the map is nothing but n, right? So if our natural number is even, then we can define a pre-image in this way, right?
Yeah.
And if our natural number is odd, then f of 2n minus 1 is nothing but n, right? And in both the cases, it is basically defined and they belongs to set of all natural numbers, right?
Yeah, I didn't understand the last bit, ma'am.
This one?
Yeah. I mean, how you arrived at this f of 2n is equal to...
From this equation. So
Okay.
if n is odd, you have to follow the odd one. Okay. So it's like f of something should be n, f of some y is n. That means if this is odd, so if n plus 1 by 2 is, n. So from here we can find the value of y.
Yeah.
Okay.
Yeah.
So you have to follow the same thing to find the exact pre-image, but you have to do it separately for even and odd numbers.
Okay. All right.
Is it clear?
Yes.
Yes, ma'am. So, ma'am, for every ma'am, element in the codomain, there will be two pre-images in the domain.
Yes, right.
But ma'am, when we put 0, so because that
For 0, we have only one pre-image.
yes, ma'am. Yeah, because when we put it 2n minus 1, it gives minus 1, which is not a natural number.
Yes, correct.
Okay.
So that means for two consecutive natural number, we have the same image. 1 and 2 will give the same image. Again, 3 and 4 will give the same image. 5 and 6 will give the same image in this way. Okay. Let us do the sixth question. We have, okay, so we were at the sixth question. So we we have the function given f of x equals to under root of 14 minus 3x plus 35 minus 5x by 4. So we have to find the domain of the function. Okay. And the hint is, if you want this to be real number, then under root something negative cannot be there. So this is the hint, and try to find the value of x with this criteria. This will be the domain.
Yes, we ensure that the second part, like which starts from 3x, this should not be greater than 14.
Yes. This is what we have now. We just have to find the value of x. And what is the domain you are finding? Just let me know. Any answer?
Yeah, x should be above. Shouldn't be above 3. It should be less than 3.
Okay, so x, you're saying that it should be strictly less than 3 or less equals to?
Ma'am, its x should be less than 3 or equal to 3 or less than 3.
This.
Yeah,
That means minus infinity to 3. This.
yeah.
So,
Okay, let us check. So what I said is, if under root of something cannot be negative, that means 14 minus this term 3x plus 35 minus 5x by 4, this should be positive, greater or equals to 0, right?
I think
That
it should be a
means-
open bracket 3, madam. No, it can't. I'm not sure if it can be.
Let us check.
Yeah.
Let us check. Okay. Okay. That means this term 3x plus 35 minus 5x by 4, this should be less equals to 14, right?
Yeah.
So 12x plus 35 minus 5x should be less equals to, what is 14 into 4?
But it can be, madam. Why less than or equal to 14? It should be less than 14.
we can take square root
No.
of 0.
Root over of 0 is also defined, right? Root over of 0 is 0,
Yeah.
Only negative is defined.
right?
Okay.
So you have to check whether the root is defined at that point or not. If the whole thing is even 0, then also the root is defined, right? Root over of 0 is a real number. Is it 0? Again.
Yeah. Yeah.
So we have to take equal. Okay. Is it clear?
Yeah.
Okay. So then the next step is also clear, right?
Ma'am, it will be 56.
56, right? Then, so 7x is basically less equals to 56 minus 35.
Yeah.
That is 21, right? So
Yeah.
x is less equals to 3, right? That
Yeah.
means this is the domain. This is the correct answer. Okay, is it fine?
Okay.
Any doubt here?
No.
Good. Okay, so that is the basic thing, how you can find the domain of the function. Okay, so in any case, if you have something, some polynomial, like 1 over some polynomial, you have to check the roots of the polynomial and you have to exclude the roots of the polynomial from real life. Otherwise, if you have under root of something, you have to start with greater or equals to 0 things. Okay. Okay, this is a graph given here. The domain and range of the function that is shown in figure 1 are nx and ny respectively. Okay.
Sorry to interrupt, ma'am.
Yes.
Could you please go back to the question, last question?
This one? This one?
Yes.
Mhm.
Yeah. Wow. What we did after that, 7x plus 35 is greater than 14. Please explain.
Then you have to multiply 4 with.
So 4 with both 3x
Yes.
and 14 as well.
You had
Both.
this 35 minus 5x by 4. This was actually less equals to 40. Now just multiply 4 with all the terms. Okay. So we will get 12x plus 35 minus 5x is less equals to 14 into 4. Right? Is it fine now?
Yes.
This is it.
Usually we do only one side, so I thought why we did.
So you
No.
can take
This is
only
the,
one side and then it multiplied by other side.
yeah, you have to do this in both the side. If you are multiplying a number in left hand side, you have to automatically do it in the right hand side, right?
Okay, and what we did next?
Then it's just normal calculations. So here we have 12x, 5x. So this will be 7x, and we take the 35 in the opposite side. So this will be less equals to 56 minus 35, which is 21. Then just take the 7 here. So it will be x less equals to 21 by 7, which is 3, right?
Yes, got it.
Just the steps follow what we follow to solve an equation.
Okay, thank you. Thank you.
Anything else?
Ma'am?
Yeah.
Ma'am, why you put less equals to sign before 14?
Because this term should be greater or equals to 0. We have under root of something, and if you want this to be something real number, then the under root of that thing should be greater or equals to 0. And if this is greater or equals to 0, then if I follow the inequality, this term will be less equals to 14. Okay.
Okay, ma'am.
Anything else from this question?
No, ma'am.
Okay, fine. Okay. So here we have given the domain range of the function as some arbitrary numbers. And here the question is, what is the value of m and n respectively? So basically you have to find the value of m and n from this figure. Again, you just try to solve this question and let me know what is the value of m and n.
So range basically covers y-axis and domain covers x-axis. With this concept, we can find the value of m and n.
Yes, correct. Domain is x-axis and range or codomain is y-axis. And you have the minimum and maximum value, you have to just take this. So what is the domain here?
So, ma'am, domain ranges from -4 to 9.
Correct. So m is equals to -4, right? And x is equals to 9, right?
Yes, ma'am.
And what is the range?
Range from 3 to
So n
One,
is
1,
equals
1,
to
2.
2, n is equals to 1, and y is equals to
9.
9.
so the value of m is -4 and value of n is 1, right?
Yes, ma'am.
That means -4 and 1, the second option. You can check whether it
Okay.
is correct or not. See, -4 and 1. And this is 9,9, right? That is what we did, 9,9. Okay? Clear?
Yes, ma'am.
Yes, ma'am.
So it was activity 11, 1.11. I think I did almost all the question from 1.11. Okay, so maybe it was the toughest activity in this week. You can solve some other. Okay. This one. Fourth question. You have to find the set M. We have given the hint. The
Ma'am, is
element
it the C option?
2, 3, 4. Yeah, correct. So
Yes,
how
ma'am.
what was the approach? What are the logics?
And because m cross m has 9 elements, it means that m singly has 3 elements. Because so we know that number of elements in the Cartesian product is equal to the product of both the sets, elements in both the sets.
Yes, correct. That means
And
it
then,
is
then we saw that there are only 2 elements of that Cartesian product, which are 2, 4 and 3, 2. So out of these, 3 are unique elements, 3 to
correct.
4.
Correct. Very good. Yeah, it was the correct reason. Okay. What about the 8th one?
Three.
What about
Ma'am,
others?
2. 2.
So all of you are agree with 2 or 3?
Ma'am, I didn't see the whole question, ma'am. I think it is related to question number 7. I did not solve it earlier.
Our R is this and S is this. Okay. What are the minimum number of element you need to add to make R symmetric? This is the question, right? And we have the R and S here. What is the minimum number?
Oh, sorry, it's to make it symmetric, is it? Not to make it
Yes.
reflexive.
I think 3.
It's symmetric.
Ah, okay.
So 3 elements need to be added to this set.
Yes, correct. So what we know by the definition is whenever A comma B is there, we need to add B comma A, right?
Yes, ma'am.
Right. So here we have snail comma frog. So we have to add the symmetric element of that one, right? And
Frog.
that is not present in the set. So we need to add the symmetric of the first, the third, and the fourth element, right? Frog comma fox and fox comma snail. That means 3 elements should be added in the group to make it symmetric. So answer should be 3. Okay. Answer is 3. Okay. Okay. So rest of the questions are, I guess, pretty simple. Okay. Let us do the first question and then I will pick your doubts only. So yeah, what should be the answer of the first question? Sorry. What is the set A? First, let me know what is the set A.
It's 1, 3, 5, 7, 9.
Okay. First of all, it should be less than 10 and it is odd. That means 1, 3, then
5, 7, 9.
correct. Okay. And B. What is the set B?
16, 25, 36.
25, 36.
16.
25, 36.
Okay. Okay. Now, what is the subset of B cross A? Now, that means the first component should be from the set of B, right? And the second component should be from the set of A, right?
Yeah.
So if I see the first,
Ma'am, is it C option?
Third option.
okay. So 16, 25, 36, 16. So all of them are member of B. Then 5, 9, 3, and 1. They are also member of this. Okay. So this is correct. So why others are not correct? What about the first one?
Because when there is 6 in the, yeah.
Second one?
6.
Ma'am, it starts with A rather than B.
Yeah. And the third one?
Ma'am, same as the previous one. Like,
Yeah. So yes. Do you have any other doubt from the
ma'am, can you please explain question number 2 as well?
this one?
Yes, ma'am.
Okay. So it's same as A cross B. We have A 1, 3, 5, and 9, right? Sorry, 1, 3, 1, 3, 5, 7, 9, right? And all the members should be from this set, right?
So it's number 1, the
Yeah.
first option.
Yeah. Okay. Second is obviously not correct because they are greater than 10. Third, 6 is there. 6 is not odd. And for the fourth option, 4 is there and 4 is not odd, right? So the first option will be correct one. Okay.
Okay, ma'am.
Yeah. Anything
There
else?
is not all members, some members are there, right? Some elements are
Yeah,
there.
but if you want this to be subset of that set, that means all member of that set should be a member of the mother set. That means all member of the subset should be the member of A cross A. Okay. Subset means sub collection, right? If all the members are also members of A cross A, then only we can say it is a subset, otherwise not. Okay. Anything else from activity? No?
Nothing at the moment.
Okay, fine. So we can maybe quickly go through the practice. We'll maybe solve 2-3 questions. Okay, what about the 8th one? Again, take some time and let me know what is the answer of the question.
Ma'am, it is reflexive and
Okay.
not symmetric. I have got these two options.
And
And then,
what about transitivity?
oh, just a moment, I'm checking, ma'am. If overlaps.
It is reflexive and transitive.
Okay, let us check the answer first, then we will solve.
Transitive only.
Okay, so the accepted answer is it is reflexive and transitive. But how?
Yes, ma'am, it is transitive.
Sorry,
Okay.
just
Something divided by itself should give you a 1. So I guess.
yeah, it is an integer. That means for any number A by A will be an integer.
Integer. Yeah.
So, yeah. So for any A by A belongs to integer. That means A is related to itself. That means A comma A belongs to the R. So this is true. Now 2 by 4 belongs to, 4 by 2 belongs to Z, but 2 by 4 doesn't belong to Z. So this is a reason why it will not be symmetric, right? That means 4 comma 2 is in R, but 2 comma 4 is not in R, right? And if A comma B comma B comma C belongs to R, that means A by B belongs to Z and B by C belongs to Z. Then their multiplication will be again a member of Z, right? Right? If I have two integer number, their multiplication is again an integer number, right? B will be cancelled out. So A by C is member of Z. That means what? A comma C is member of Z. So whenever we have A comma B and B comma C is R, then we can conclude that A comma C will be a member of R, right? That means it is transitive and it is not equivalent because not symmetric. Okay, is it fine?
Yes, ma'am.
Okay. What about the 10th question?
Ma'am, F is injective.
F is injective or not?
Ma'am, it is because for every X in the domain, we can get an image in the codomain, but it is not surjective.
You are confused between the definition of injective and surjective function.
It cannot be injective, right? Because for a
Injective means
negative,
1 and
It's
surjective
not
means on.
injective.
Sorry, ma'am, yes, ma'am, injective it
for
cannot
a
because yeah,
negative, yeah.
for
So
like
1 is
1 in
not
90%.
equals to minus 1, that f of 1 is equals to f of 1. Right? So not injective. Right? And what
Yes,
about
ma'am.
surjectivity?
Oh.
Ma'am, it is surjective.
So can we find any pre-image for minus 2? Minus 2 belongs to the codomain, right? Is there any pre-image for minus 2?
No, ma'am.
So it will not be surjective, right?
Ma'am, it's not surjective.
Because see, x square is always greater equals to 0. So x square plus 2 will be always greater equals to 2. That means the value of x is always greater equals to 2. That means the range is 2 to infinity. And range is clearly a proper subset of real number. If it were on 2, then range were equal to the codomain, right? But this is not the case. That means it is not surjective. It is not injective, neither injective nor surjective. Okay? Any doubt? Any doubt from here?
I'm
Is it fine?
sure.
Okay. Anything else from practice assignment?
Yeah. Okay.
Is someone
So
saying
many
something? Yeah.
Diti. चलो 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 मैम साइड में ना शू भी दी इधर
What is going on?
सूट
Okay. Anything else? Any doubt? Any question? Maybe related to concept, maybe related to any problem.
Can I do the 11th one?
11th one means from practice assignment or what?
Yeah.
This one. This one.
Yes.
Okay. So we need to find the domain of the function. So we have to find the points where the function is defined, right? So what should be the domain according to you? Just take some time to solve, then let me know, then I will solve. We have 1 upon some polynomial, we have under root of some. So we will get two different criteria and have to follow them to find the domain. What is the domain? Just one step. Just one step. You can do it.
Is it the first option?
Okay, you're saying it's first option. Okay, let us check. So if I want to, if to be defined, that means x square minus 9 should not be 0, right? That means x should not be plus minus 3. And the second thing is x plus 2 should be greater equals to 0. That means x should be greater equals to minus 2, right? Now, if x is greater equals to minus 3, it will be automatically greater than minus 3. So, it will not be equals to minus 3. So, it should be greater equals to minus 2 and x not equals to 3. That means the first one is correct. Is it fine?
Yep.
What does real valued function mean?
Real valued function means the codomain is the real number. That means the value f will give will be a real number. Okay.
So the output can be anything. Means the domain can codomain can be anything.
Codomain maximal codomain can be real number. That means you cannot put any complex number in the place of image of some element. So the image should be a real number. That's it.
So real valued function
If
means
I take suppose minus 4, okay, then we will get a complex number, right? As an image, right?
Yeah, ma'am.
yeah. So real valued function means from
The
real to
image-
real.
No, real valued function means f will be from some domain. I don't know what is the domain, but the image should be in the set of all real numbers. That means the codomain should be R. If it is real valued function means the codomain is R simply.
The codomain is R. Also, domain should also be R. Is it? Is that a necessity?
No. Domain here, the domain is not R, right? We are restricting the domain. Domain is a subset of real number. D is a subset of R.
Got it.
Okay. D is a subset of R. Domain can be anything, and the codomain should be real number. That means the value of the function is a real. So this is a real valued function. Okay. Any doubt? Any doubt in this question?
How do you indicate that the codomain also has to be real number without actually writing this, like without actually having to write domain of the following real valued function?
Yes.
So in this expression, it's very clear that the domain has to be a real number. But how do you
Codomain.
make
Real valued means the value should be the value of the function. The functional value is real. That means the image should be real.
okay, which means the codomain, right?
Yes, which means the codomain.
Okay, but is there a way to express that without having to write this? Like how you write a relation here? These are relations, right? And
Yeah.
these are expressions for relations.
Yeah,
where
this is another way to write it, right? It's a
Okay.
subset of R, and f is a function from D to R. That means
Okay,
it is a
okay.
real valued function.
Okay.
So these are just same statement, just
Okay.
other way to express them. Yeah. Yes.
Ma'am,
anything-
can you do question number 9?
Question 9. Okay, so again we have to find the domain and range of the function. Okay, what should be the answer first? Let me know, then just solve. Again, we have the root thing. That means under root of this should be positive, and we have to start with this condition, right? So if x3 minus x should be greater equals to 0, that means x should be less equals to 3, right?
Yeah.
So the domain will be x belongs to R such that x is less equals to 3. Now what should be the range? Range
Ma'am,
will be,
would the answer be the third option?
that is what we are checking. So this is our domain. Now x is less equals to 3. That means 3 minus x is greater equals to 0. So under root of this will be again greater equals to 0. So this is our range, right? R such that x belongs to R such that x is greater equals to 0. That means third option is the correct one. Okay. Is there any doubt here? Yes.
No, why is it that it mentions x in the range? It mentions x has to be greater than or equal to 0.
This is the for any x satisfying this. This is the functional value, right? That means fx is greater equals to 0 now. Now you can put y equals to fx where y is any point in range. So this y will be greater equals to 0, right? So we can express now range as y belongs to R such that y is greater equals to 0. And
Okay.
these are just variables, right? So you can replace
So
them.
it's just that it's instead of x, y, they've used x.
Yeah, yes. They're just variables, so you can use the same
Okay.
to express the set.
Okay, ma'am.
Clear? Is it
Yes,
clear?
just hang on, ma'am. Let me just screenshot it.
Okay, sure.
Ma'am, can you close that little
Like that? Is it fine?
yeah. Can you zoom out, ma'am?
Yeah. Is it fine now?
Yeah, ma'am.
I think it is clear to all of you, right? So I will delete this if it is clear. Okay. Anything else? Anything else? I think I solved most of the questions. Do you have any other doubts on this maybe activity or practice? Or it may be something other than that also. If you have some external doubt on this concept, you can also present them. You can take a screenshot that problem and share it in the chat box. Is there anything? I am done from my side. Now it's up to you. If you have any doubt, you just share. I will solve. Otherwise, if you don't have any doubt, you can leave.
Hello, ma'am.
Yes.
I need your help. How to understand this function and relation? I'm stuck with it. I don't know how to understand this.
Okay. So the thing is, you just read the definition and try to understand the definition with some examples, like the Venn diagrams or some
I
sets.
understand this Venn diagram and all, but when it comes to the written the statement, I'm not able to understand how to solve it.
Okay, so the domain and codomain type of question or what?
Yeah, that kind of this I understand, this union and intersection and all.
Okay.
Then there is no problem.
Okay,
But
so for domain and codomain, the most thing is you have to first find the domain. That means the points where you can define the function. And to understand this, you have only one key. You have to practice so many problems. So you just try to first solve all the activity practice, and even if it is still you are not comfortable with it, try to solve any external problems. You can collect anything from the Google itself, and you just try to find the domain and codomain of those functions. Okay. So only for anything in mathematics, you have only one key. You have to practice them.
yeah, but I'm stuck only with this thing only, this domain and codomain and function. I don't understand how, when I will be able to.
This is the way. Whenever you will have some the point to get some 1/0 or root over minus of something. These are some point where this function cannot be defined. So you have to exclude them, that points, right? So I solved 2-3 more problems for to find the domain and codomain, and you have to follow the exact procedure to find the domain and codomain, and you have to solve some problem based on that. Okay, so this is the only way you can improve those things. You have to solve plenty of problems like that. You can
Okay,
follow
ma'am.
any book which is mentioned in the site. Also, you can collect any random problem from the Google and just try to find the domain and
Okay,
codomain
I
for
will
any
try it.
random function. Yeah.
I will try it.
Yes, yes, yes.
Ma'am, I have a
Okay, thank you.
question.
Hmm.
So can you hear me, ma'am?
Yes, yes.
So if let's say there is a set, see an empty set is supposed to be a part of a superset, right?
Yes.
So so when you're going to try when you try to take a what do you call the number of items in a set? It's cardinality. So when you take the cardinality of a set, and let's say there is another set within the set,
Okay.
do you have to take the number of items inside the subset also when you take the cardinality, or the entire set is considered as one?
What?
So if let's say there is a set which contains two sets.
Can you like start with some example? Try to construct some example, some 1, 2, 3 like that.
Yeah, there is a set A which contains another set inside it, B.
A. Okay, that means B is subset of A.
Yeah, and it also contains another set, C.
And okay.
No, B. So A.
So
Yes.
you are saying this or what?
Yeah, no. You're right, ma'am. And so B contains two items, two elements, and
That means cardinality of B is 2.
B is 2. C is also 2.
Okay.
Cardinality of C is also 2. So cardinality of A, would it be 4 or would it just be 2?
Cardinality of A can be anything, but it will be greater or equals to 2. That is what we can say.
Okay.
That is what we can say. Actually, greater equals to the maximum cardinality of all the subsets. That means if we have any subset of A, that means cardinality of that subset will be less equals to cardinality of A.
Ma'am, for example, say
If I
there
take
is a set.
A equals to, for example, 1, 2, 3, I can take B equals to 1, 2, C equals to 2, 3, right?
Okay.
So the cardinality of A is 3, which is greater or equals to 2. Now you can take this also, and then C also you can take as 2, 1. Like
Okay.
B and C are same. Then the cardinality of A is 2, right? So
Okay,
in
ma'am,
that way you can take anything which is greater or equals to 2.
Okay. Okay. So when you say there's no, it's only when you take a power set that a empty set is also included in it, right?
Yes.
Okay. But a regular set, not a power set, does not need to include a
The empty
null
set
set?
is null set is subset of any set. So if you are considered, like if you are talking about subset of any set, then null set is a subset of any set in any case.
Okay, a null set.
Yeah, a null set is subset of any set.
Okay, so why don't you include that in the cardinality?
Because it is a subset, not an element. So it is an element of the power set. Okay.
Okay.
So if I have a set, phi is a subset of A. So it is not a member of A, but this phi, it is a member of power set of A.
Okay. But it is not a but it is also a part of the, okay, it is a subset of,
Yeah, it is not an element of A, but it is an element of power set of A, because
But-
all the elements of power set of A are subsets of A, right?
but if something has to be a subset of a larger set, then it has to contain that set, right?
Yes, it contain the set means this subset sign, and being like subset and being element, these two are different thing, right?
Okay.
If I take this A as suppose 1, 2, 3 and B 1, 2, so B is a subset of A, but we cannot say that B belongs to A, and this is the same case, right?
Okay.
We cannot say that B belongs to A, but B is a subset of A, right? So phi is a set. Now you have a set which collects
Ma'am.
the numbers. Now a
Okay.
set cannot be element of that set, right?
Ma'am, can I just ask you a pretty silly question? So,
Yeah, sure.
so B, you're saying, is a subset of A.
Yes.
So shouldn't B also belong to A?
No, never.
Why?
Because all the elements of A are what?
No, if it is a B, if so, all the elements of B exist in A, right?
Yes. That is why we are saying that B is a subset of A, right?
Yeah.
Now all the elements of A are natural numbers, right?
Okay.
Is B a natural number? No, right? All the elements of B are natural number, but B is not a natural number. B is a set of all natural, set of some natural numbers, right?
Okay.
Set
Okay.
means what? Some well-defined collection, right?
Yeah.
Here the elements are natural numbers, but B is not a natural number. Phi is not a natural number. You cannot push them to be an element of the set. Okay.
Okay.
That is what we need, the well-defined word, right?
So are you saying because B is actually a set?
Yes, B is
And-
actually a set, and phi is also a set.
Okay. When you say phi, you mean the symbol for an empty set?
Yeah.
Okay. So when you say B does not belong to A, that's because you don't want to do an apples against oranges comparison. Because
Yeah.
B is a
So
set.
B is not an element of A, right? B is a set of two elements of A. So subset is never an element of that one, but a subset of A is an element of the power set of A. Okay.
Okay. Ma'am, it's very clear now. Yeah, I get it.
Very good.
Ma'am,
Yes.
ma'am, is 2.5 an integer?
No.
So ma'am, I've put a question in the chat. Can you please check that? It asks the number of integers in the list of numbers.
This one.
Yes, ma'am.
Okay. So under root 3, we don't have a number. So this is a irrational number. So this is not integer. 2.5 is a rational number. E is a irrational number. Root over 49 is 7, right?
Yes, ma'am.
So it is a integer, right?
Oh, okay. That was the only one I was missing then.
This is integer. It is a rational number. It is a integer. It is a irrational number. It is a integer. This is a irrational number, but it is an integer. It is an integer. Okay.
Okay, ma'am.
Anything else? Anything else? Any other doubt?
Sir, I have a question apart from this chapter, means from this one question here. May I ask?
Yes. What is the question?
Ma'am, till now I have not done activity questions, so that I can see the clues and I have attended the classes first so that it will be easy for me to attend activity questions. So
Yes. So you just go through the concept once, then maybe you just go to the last live class first, the summary one, and then try to solve the activity questions.
okay, ma'am. So is anything going to happen? Means that I was asking.
What? No, it's not at all a problem. Like you just, it will maybe take 2 to 3 hours to go through the lecture, and then you just solve them, and they are easy enough. And we also have the recorded version of that problems too, so you can also go through of them. You can find them in the YouTube channel itself.
Okay.
Okay.
Because in maths, I was saying one thing. Since 11, 12, I'm having one problem that whenever any new problem comes, honestly speaking, that if any new problem or any new sums come, then I do not use my mind. Like,
Okay, that is a bad habit. You just first try to solve them using your own mind. Then if it is not, somehow you cannot do that, in that case you can take help of some other sources. Otherwise you just first try to solve it by your own. Okay.
firstly, seeing the videos is not a good option.
No. Don't see the video first. You just try to solve them by your own first. Okay. You just try to spend some 2, 3, 4 hours for that. If still it is not happening, then go for the videos. Otherwise not. Okay.
Okay. So firstly, you recommend to solve the questions, then I
Yes.
can watch these
Yes.
live sessions in YouTube.
Yes.
The solution.
First try to solve them with your own. If you can solve them with your own once, then you will never forget them. Right?
Okay.
Otherwise, you will forget after some time. And you again have to see the lectures. So this is the best way, right? You just try to use your own to solve them.
And one more doubt I had, that the lectures which are in the dashboard, they are a bit long. So any summary lectures are there, that I was asking.
Yeah, summary live sessions are there. Also, previous year summary lectures are there too. So you can go to that. Okay.
And in supplementary contents also, short lectures are there.
Yes. You can go through them. Yes.
Okay. Those supplementary contents with summary lectures, are they sufficient for CGPA? This was my last.
So the thing is, you need to practice them. You need to adopt the concept for CGPA. The questions will be moderate level, but you should have the concept to attend the questions.
Yeah. So I was just asking that will I be able to solve that question just if I watch those supplementary content, these live sessions?
Okay. So I will suggest you to go through the lectures because you need to understand the concept properly. So try to go through the lectures, at least the summary session. Okay.
Okay, ma'am.
Ma'am, any recommended book, ma'am?
So book is there in the website, I guess. You can follow this book. Otherwise, there is a book, SK Mappa. You can follow this book, Real Analysis by SK Mappa. And also the book for this course is
Where is that book, ma'am?
I think it is given in the website also.
I've downloaded about 3 PDFs from the website. From the
which website?
So they are
not the website, the IIT portal.
Yeah, maybe you can find
portal
it
where the account is, where our accounts are, and I'm not sure. I'm still not
I
very
got
familiar.
only statics one.
Okay, so what you can do is, if anybody of you have the file, you just share the file in the
please
chat box.
Can I do that? Am I allowed to do that? Because
Yes. Yeah. You can do it.
Yes, please share the.
You can follow that book for this.
Ma'am, I have sent a question chat. Can you please explain that?
Okay. Okay. So what is the question? I mean, what is your doubt in this question?
Ma'am, shouldn't it be that X is not a set because like it's a collection of random things?
Yes.
But ma'am, the answer is given that X is a set because it is a collection of different things.
Okay. See. Here. I mean, there is. Yeah. This is correct one. Maybe because here you don't have any like definition. How can I explain it? Like if I had this, like some x is some x such that this x is suppose some number, okay, or yeah, x is some number. Now here you have a definition in the set, and I mean that some number can be anything. Don't know what is that some number exactly is. So here you have a confusion. But here in the example, they have defined the x. I mean, particularly this 6 things. So you have the like you have the 6 things which is in the set. Are you getting my point?
So basically that there was no definition of the set given
Yes.
before, so we cannot say that it is not
Yeah.
well
So
defined.
that means yes. So that means this set is same from anyone's point of view, right? You can see the set of this 6 member, and anyone in the universe can see the same set. That means it is same universally. Whenever it is same universally, that means it is well defined, right?
Okay, ma'am. And ma'am, one more thing, can you explain the difference between proper subset and subset?
Okay, so what I said is a proper subset means it cannot be equals to the set, it cannot be empty set.
Ma'am, can you
subset
repeat?
is-
Your voice was not clear.
Okay, let me write it. A subset is proper. B subset of A is proper means B is not equals to 5 and B is not equals to A. Okay.
Okay, ma'am.
Anything else?
Ma'am, she's asking very genius level question.
Fine to ask. Like you can ask anything is bothering you.
When are the sessions happening? This is happening at 8 to
8
10
to 10. Yeah.
on Saturdays, and then when is
Saturday
that?
and Tuesday.
Tuesday again 8 to 10, is it?
Yeah. Same timing.
Okay. Okay.
And TA sessions are from 4 to 6.
TA sessions are from 4 to 6.
Yeah.
Okay, both Tuesday and Saturdays.
No, not Tuesday, Saturday. I guess it's Tuesday, Thursday, Saturday. I'm not sure. You can check it in the calendar.
In calendar is not, it's not very clear. It says 2:30 p.m. max one session.
In calendar, the TA sessions will be mentioned there. You can check it. From 4 to 6 TA sessions are there. I'm not very sure about the dates. Okay, let me check it once.
It's not very clear in the calendar. That's why I'm asking. Sorry.
Okay, so Sunday we have a TA session. Saturday, Sunday, Wednesday and Saturday, Sunday, and Wednesday we have the TA sessions 4 to 6. Okay.
On Tuesday and
Tuesday
Saturday?
and Saturday you have the instructor session from 8 to 10. Like total 5 sessions are there per week.
Thank you.
So any other doubt? If you have any other doubt, you can ask. Otherwise, please.
Thank you, ma'am.
Yeah, welcome.
Equivalence relation and
Thank you, ma'am.
equivalence class.
What?
Equivalence relation and equivalence class.
Equivalence class. Okay, so equivalence relation is, we know that equivalence relation means what? What is the definition of equivalence relation? Means reflexive plus symmetric plus transitive, right? If a relation is reflexive, symmetric and transitive, all three, then we say that relation is equivalence relation. Now, equivalence class is a class, we defined it that in that way. It is a collection of all B such that A is related to B or B is related to A. Okay, equivalently. Okay.
Can you repeat that?
Equivalence class is collection of all those elements which is related to A. Okay.
Okay.
That means if I have that A is related to B, okay. So suppose you have a equivalence relation and AB, BC, comma, AC is there. AA. C. Then we need to make it equivalent, means again we need BA, C, D. Is it now equivalent? Is it now equivalent?
Yeah.
Okay. Now, what is the equivalence class of A? Those B which is related to B. That means some A comma B or A comma C. So we have A comma B is there in the relation. That means B is related to R, right? Sorry, B is related to A under the relation R, right? That means B will be in the set A. Again, C is also related to A, right? Because A, C and C A is there. So C is related to A. So C is also in the set R, A. Okay. That means here we have only equivalence class. So whenever we are saying that B belongs to the equivalence class of A, that means A comma B belongs to the relation R. Okay. And this is what we symbolize that A is related to B. Okay. That means A comma B belongs to R. Is it clear? It is the definition of equivalence class. Is it clear?
Ma'am, in easy words, it means that all elements of A will be related to B or B
No,
will
no,
be
no, no.
related to
It depends upon the relation. It depends upon the relation. Okay.
How does equivalence relation split the set equally? As I read somewhere that equivalence relation split the set. How will it
Split
do?
the set, but not equally. I mean, equivalence sets, equivalence relations partitions the set. So if I take an example, suppose we have the set 1, 2, 3. Okay. And let us take the relation 1, 1, 2, 2, 3, 3, then 1, 2, then 2, 1. So it is a, first of all, this relation is equivalence relation or not? Is it equivalence or not?
Yes.
It is equivalent, right?
Yes.
Now, what is the equivalence class of 1? According to the definition?
1 and 2.
Right. And equivalence class of 3 contains only 3, right?
Yeah.
Now their intersection is 5 and union is the whole set, right? Right?
Correct.
That is the definition of
Yes, ma'am.
partition. That means partition is a collection of subsets such that their union is the whole set and intersection is the 5. So that means if I have the whole set A, partition is like that. Okay. This is one set, this is second set, this is third set, this is fourth set. So their intersection is 5, but their union is the whole set. Here we have this. This is first set, equivalence class of 1, and this is equivalence class of 3. Their intersection is 5, but union is A. Is it clear now?
Yeah, but I have you gave an example of how equivalent relation partitions the set.
Yeah.
I'm asking how does the 3 property of being symmetric, reflexive, and transitive is making the set behave like that? Why is the 3 feature making the set behave like that is my question.
Okay. So it's like 1 and 3. So here also, because symmetric means what? If 1, 2, suppose AB is there, means BA will be there, right? That means if A is related to B, then B is related to A. That means in both the way, so if suppose A is related to B and B is related to C, okay? That means what? B belongs to equivalence class of A and B belongs to equivalence class of C, right? But
Correct.
if it is transitive, then it will imply that A is also related to C. That means C will be in the equivalence class of A and they will be same, right?
Correct.
Right?
Yeah.
But suppose this condition was not there, okay? Okay? This condition was not there. Then A, suppose is not related to C. That means it is not transitive. That condition of transitivity is suppose not there. That means we have A is related to B, B is related to C, but A is not related to C. For suppose, okay. Then we have B is in the equivalence class of A, B is in the equivalence class of C, but C is not in the equivalence class of A. That means the intersection of equivalence class of A and C is not 5. Got it? But they are not same. Because C belongs to equivalence class of C, but C does not belongs to the equivalence class of A. So it is somehow not maintaining the condition of partition, right? That means it will imply the equivalence class of equivalence, this is not equals to 5 because B belongs to both of them and they are not identical also. Because C does not belong to the equivalent class of A. Okay.
C belongs to the equivalence class of A. So you're saying A, B, C all belong to the same class?
Yeah, because of the transitivity property. But if this condition were not there, the transitivity condition, then C will not be in the equivalence class of A. Right?
Correct.
If C is in the equivalence class of A, then A have to be related with C, right?
Yeah, I understood a counter, like when transitivity is not there, C couldn't be, we cannot compare C with A and all that.
Yes.
But my question is, we have some elements and we apply this symmetricity, transitivity and reflexivity, and even it could be one single class of element, like the
Yes.
entire set could have even just
Yes.
one single class.
Yes.
But how do we get the intuition that it will equally, like, where is this partition coming into picture? Is that intuition I'm not able to get. That's why I'm asking you.
Okay, so you have to check the relations for here. Like here we can see that there were 2 different equivalence classes, right? That means 2 different partition. Now on the same set, you can define another relation with 3 partitions. Similarly, you can define another relation with 1 single partition. So all are possibilities. So on a set, you can define several type of partitions depending upon the relation, equivalence relation actually. You can define on a set, you can define an equivalent relation in several ways, right? If I take the identity relation, then we will get 3 different equivalent classes, right? It will be a partition of 3 elements or 3 sets,
Correct.
right? Similarly, if I define this, that means we get a partition of 2 sets. Now we can also define a set in such a way so that we can get a partition of 3 sets. Okay.
Yeah, all your examples I'm able to understand, but that intuition of why, see, we are saying a tautology, right?
Yeah.
3 features, 3 reflexive, transitive, and symmetric 3 features is a tautology of set being partitioned into equal, it partitioned properly. That tautology I'm not able to understand intuitively. Maybe I'll learn maybe after some time.
Yeah. You may have to sit with this because I guess I'm not getting your exact doubt.
Yeah.
Ma'am, here if I write in R 3 comma 2, then equivalent class of 3 will be 3 comma 2. Am I right for that?
If you write 3 comma 2,
In R, if I add also 3 comma 2.
okay, then again you have to add 2 comma 3 also, right? Because R
So
is a
for
equivalent
class,
relation.
so for equivalent class, firstly it should have equivalence relation.
Yes. First of all, that R should be a equivalence relation. Then you can define the equivalence class. Otherwise not.
So we have to also make symmetric and also transitive and reflexive.
Yes.
Then we can
Reflexive,
say.
symmetric, transitive. All the 3 properties should follow. R should follow all the 3 properties. And R should be a equivalence relation first. Then only you can define a equivalence class using R. Otherwise not.
Suppose if any relation is equivalent class, then it must should be equivalence relation.
Yes. If you are defining a equivalence class, means that relation should be equivalence relation first. This is the first step of the definition. Otherwise, we will not talk about the equivalence class. Okay.
So every equivalence relation will be equivalent class or not?
No, they're not same. I mean, first we have to define an equivalence relation. Then we will define an equivalence class with the help of the equivalence relation. They are not same. They are not comparable. They are different.
So vice versa is not true.
No, never. So in order to define equivalent class, you first need to have an equivalence relation. Without equivalence relation, you can never define an equivalence class. Okay.
Yes, ma'am. And ma'am, when we can say anti-symmetric?
Anti-symmetric means it is not symmetric. That means AB belongs to some set. It will imply BA does not belongs to the set. It's anti-symmetric. And asymmetric is AB and BA is in the set. That will imply A equals to B. Anti-symmetric and asymmetric are not same. Okay.
Last time you said about asymmetric.
Yeah. Asymmetric means is AB and BA is in the set, that it implies A equals to B. And antisymmetric means AB is there, that implies BA is not there in the set. That means exactly the opposite definition of symmetry.
Symmetric is also in our syllabus.
No. You just need to you need not to be bothered about antisymmetric. Symmetric relation is fine.
No, there was an option anti-symmetric. That's why I was asking about that.
Yeah, antisymmetric means simply keep it in mind that it is not symmetric. If it is not symmetric, that
now
means
it's clear.
not antisymmetric. Okay.
Thank you, ma'am.
Yeah.
I think you interchanged antisymmetric and asymmetric definition. Antisymmetric can have loops, no reflex. It is
Antisymmetric means asymmetric means is AB and BA is in the relation. It will imply A equals to B. This is asymmetric.
Oh, I think this is antisymmetric.
This is asymmetric.
No,
This is not-
asymmetric doesn't have loops, no.
That is what the result is, no?
Uh,
That is what the result is. If you have the loop, that means they will be same.
Asymmetric is reflexive relation.
And antisymmetric is A, B belongs to the set. This will imply B comma A will not be in the relation.
So, ma'am, asymmetric will be reflexive.
It may be reflexive, may not be reflexive also. May not be reflexive also. That means if I take this set, suppose 2, 2, this is a asymmetric set over 1, 2, 3, but this is not reflexive, right? This is a asymmetric set, but not reflexive. So antisymmetric does not necessarily mean it will be reflexive. Okay.
no, this is actually antisymmetric, not asymmetric. I think you're interchanging the definitions of antisymmetric and asymmetric. I am
Ma'am, I
actually
don't think so.
checking
May I
it.
leave the meeting?
No. This is asymmetric. And this is antisymmetric.
As ma'am, I think he's saying right. A equals to B is antisymmetric, ma'am.
Actually, you're interchanging the definitions.
Yes, ma'am.
Let us take it.
Asymmetric doesn't have loops. That's the basic idea.
Okay.
So it can't have reflexive property.
Okay. So this is antisymmetric maybe. Is it fine now?
Yeah,
Yes,
fine.
ma'am.
Thank you.
Anything else?
Ma'am, I have sent 2 doubts in the chat.
Okay. So what is the answer of this question? These are some these are basic questions. So you should solve this by your own. Right?
Ma'am, will the answer be the second option?
Yeah, obvious, right?
But ma'am, it's a multiple choice, so
Hence,
should there be another option?
is it multiple choice or multiple select? Which one?
Ma'am, multiple select, sorry.
Yeah. So
Ma'am, the third option is also correct besides the second one. Yeah.
yes, correct. Root over of n. If you just take, so you just take root over of n. You can replace with some n squared. Then n is less than 1 0 0 0 0 means root over of n will be less than 100. So it will be the same. Second and third option are same. Okay.
Okay, ma'am.
Okay. Yeah. What about this one? What will be the answer of this question?
Ma'am, do the symbol of the second option and the first option mean the same? Like the intersection and the divide sign?
No, this is not the divide sign, first of all. This is set subtraction. So you have to exclude the interval from the first interval. Okay. And intersection means you have to take the common portion. So what will be the answer? This is a question to everyone. What will be the answer? first of all, I'm taking intersection with 0, 3, means the upper bound will not cross 3, right? So it will be less than 3, the upper bound. X, the upper bound u will be less than 3, right? Because we are taking the intersection. And now let us check this set. So here the lower bound is 2, open 2. So the lower bound L will be strictly greater than 2. So this set L comma U, this will be subset of 2 comma 3, right? So it will be subset of 2 comma 3 closed interval also. Is it not?
Yes, ma'am.
So that is how you have to check the subset things. Okay.
Okay, ma'am.
Anything else?
So week 1 is what we are covering right now, correct? Week 2 will happen in subsequent sessions.
Yes. Next Tuesday, the summary session of week 2 will be there. Then Saturday, we will follow the same thing.
Thank you.
Okay. So if you don't have any doubt, you can leave.
Thank you, ma'am.
Thanks a lot, ma'am.